Hello, how are you doing? Good morning. Good morning. Thank you so much for joining me with another math lesson with Mr. Woodford. Today, I want to talk about word expressions and also combining like terms. This is regarding math lesson objective 7.1 of the Math 7 curriculum. Let's dive right in. If you're joining me on Google Classroom, or if you're joining me just to watch the video over again, please pull out your packet, pull out your worksheet to be able to dive into this activity, to be able to follow along with us. First thing that you're asked to do, as usual, is to complete some bell work. The bell work that you're asked to complete today is to fill in this word bank. Fill in the word bank with the correct words for each operation. So there's addition, multiplication, subtraction, and division. I want you to fill in these words, right? Less than, more than, times, twice, half, split, difference, sum, product, quotient, triple, equal parts, multiply by, decrease by, subtracted from, plus, minus. Put them in their respective location. Now, I don't believe that this should be a difficult exercise. And just to go over just some of the words, I'm not going to go over all of them. Less than, we should know that that's subtraction. More than, we should know that's addition. Times, we should know that's multiplication. And half, we should know that's division. Twice is also multiplication as well. And you just go through each one of them and make sure you identify which one belongs where. Okay, these are keywords. They're very important for us to be able to identify what we're going to be doing today. Now, what we're doing today is we will simplify algebraic expression and combine like terms, right? We will write algebraic expressions from word problems or from word statements. And then eventually we're going to go into combine like terms. But to start off with, I want you to identify each of these words as an operation. When we're reading word problems, it's important for us to be able to read the word problem and say, okay, I know what it's talking about. I know the operation it's talking about because I can identify keywords. These keywords are significant. But another significant thing before we start interpreting things is I want to show you two different statements and want you to tell me what the difference is. So when we look at this expression and look at this equation, right? Notice I call them something different. I call one an expression, I call one an equation. Now, why is that? Why is one considered an expression? Why is one considered an equation? They both have x plus 6, but this one just has x plus 6 equals 3. So what's the difference between these two? And what makes this one an equation while that one's an expression, right? If you said because this one has an equal sign, you are correct. Right, you are correct. An equal sign is the difference between an equation and an expression, which is something that we should hold on to and remember. Today, I may actually write expressions, which means that you should have no equal sign. But if I said to you, write an equation, that means that there should be an equal sign. All right, let's look at the other side here. Numerical and algebraic. What is different? What is the difference between these two? Take a second, write down your thoughts. Analyze these two equations over here because they're both equations now. But what's the difference between a numerical equation and an algebraic equation? All right. If you said, all right, when I look at the both of them, Miss Warford, there's a -3 here, but there's an x there. Good. That is the obvious difference. But what makes this one algebraic? Which one makes this one numerical? The reason this is called numerical is because it only has numbers. Numerical means numbers. It's a number equation. As this one here has an, it's called algebraic, it's because it has a variable. That's why we're in pre-algebra. That's why we're solving for unknowns. This is a variable, which makes this one an algebraic expression. So whenever you see a variable inside of an equation, that means that's an algebraic equation, no longer a numerical equation. That is the difference. One has a variable, the other one doesn't. All right. What I want you to do is this. I'm going to show you how to do two of these problems down here in independent practice 1. And then I want you to be able to do the rest. You can pause the video, you can do the rest. It's up to you. I'm gonna, after I do 1 or 2, I'm gonna take a second, let you breathe, take a second. If you need to rewind it, look at it again. I'm gonna continue on to the modeling, which is really what I want to get into today. But I want to show you how to interpret some phrases, some sentences, and put them into math symbols. So I'm going to do number 1, and I'm also going to do. Let's see. I'm also going to do number. Let's do number 6. Okay. So number 1 says the sum of 7 and a number. Now remember when we first started our chart this morning, you should have figured out, okay, what does this word sum mean? What operation is this sum? Now, what I like to do when I'm interpreting word problems is I like to underline them, and I also like to put the symbols above them. That way I can recognize, okay, what am I talking about, okay? Now, this word sum of, right, you should recognize the word sum of is the answer to addition. It's the answer to addition. So it's not addition in itself, honestly, it's the answer to addition. So if you want, you can put a plus sign here. And the one thing about this particular plus sign, it actually goes, it says the sum of, and the plus sign always goes where the word and is. Just like if we've seen product, quotient, or difference. Those words are the answers to the operations. The sum of is an answer to addition, and it means add, but we need to add two things. And we're going to put this plus sign where the word and is. We have a 7 here, right? We have a 7. We're going to put the plus sign in the middle, 7 plus a number. Now, a number is a fancy way of saying a variable, right? A variable. And in this case, let's just use the letter X, right? So we're saying 7 plus a number, which in this case, we said a number represents X. It can represent N, it can use Z, you can use whatever letter you like. I'm just using the letter X in this case. So when I write this expression, because these are expressions, it's going to look something like this: 7 plus X. And that's what this expression is. So I'm going to read it again. This is the sum. That tells me the sum of means this is the answer to addition. But that plus line is not going to go in the front of 7. It's going to go in the middle where the word and is. Okay, so the sum of plus 7. 7 plus, okay, that's what we got so far. 7 plus a number. A number represents the letter X. Notice I'm annotating above it. Notice I'm underlining underneath it. I'm trying to really interpret each part of the phrase. That is your goal. Do not try to just quickly go through it. Take it one word at a time and say, okay, does this word represent an operation? Does it represent a number? Does it represent a variable? Right? Take a second to internalize this stuff so that way you can get it. Right? And once again, if you don't know that this is a variable, I would recommend making sure you put your notes here and state that the letter X, the letter N, whatever it is, it's a variable, also known as a number, right? That's what the word phrase is going to tell you, that this is a number. Okay? It's a number that we don't know at the moment. And let me go to 6. I'm seeing 7 here. That's why I kept doing that. But 6 here says 3 is subtracted from a number. I've read it one time through, which is another technique I like to use. Read it one time through, and I'm going to go through it. So I see the number 3 here. So I'm going to put 3 right above that because that means that's 3. Is subtracted from. Now, you should know the word subtracted does indicate subtraction, right? However, because they're using this word subtracted from, I'm going to write in parentheses here, switch, okay? Because this is like the word less than. Subtracted from and less than are the same. If you want to put a note somewhere, you could say subtracted from and less than, they're the same technique. Right? What technique is that? That technique is switch the two around. Switch whatever was in front, it becomes second. These two are the same thing, right? And let me show you what that means. So it says 3 is subtracted from, that means minus, but I'm going to put switch, means I'm switching the two numbers in their order. A number represents the letter X. So I have 3 minus X, which it should look like, but because I got to switch them around, it's going to be X minus 3. Okay, whenever you see the word subtracted from or less than, that means switch the order of the two of them. Switch the order of the two of them because it's really saying the first one should be last and the last one should be first. So in this case, instead of being 3 minus X, it's going to be X minus 3, and that is my expression here. So take a moment if you need to pause the video, rewind it if you need to copy down some of the notes, whatever you need. Finish the rest of these independent practice 1. On the next second or so, I'm going to go on to the next page and begin to work on the modeling. All right, awesome. Let's go. Now, how do you add and subtract algebraic expressions? So we talked about what an algebraic expression is. We know expression means it doesn't have an equal sign. We know an algebraic expression has a variable in it. But now if I said to you, well, add some algebraic expressions, right? You know how to interpret them. You know how to write them and translate them. You know what one is, you know what one's not, right? But now if I said add them together, how do you do that? And that's something called like terms. That's something regarding like terms. So if you look at our vocabulary, we're talking about expressions, right? It's a sentence with a minimum of two operations or two numbers and at least one math operation. Sorry, okay? But we also need to know something called a like term. A like term are terms that have the same variables and same powers. Let me say that again. A like term has the same variable and the same power. The coefficients do not need to match, okay? Now, there are three things to a term, and I'm going to explain that to you, all right? I'm going to explain that to you, but for right now, I want you to write down these notes. In order for you to understand what a like term is, you can only combine like terms or terms if they have the same variable and the same exponential power, right? Exponential power, exponent power. All right, I'm gonna exponent power here. What do you mean, Miss Wilford? This is a little confusing to me. I'm not getting it. Let me explain to you. Imagine if I had x to the second plus x. These you can't combine. They have the same variable. The letter x is here. But they also need to have the same exponential power. And if you look here, right, the exponent of the first one is 2, whereas the exponent here is 1. Whenever you don't see an exponent, that means the exponent there is 1. However, if I want to go and add something that looks like this, 2x squared plus 3x squared. They have the same variable, x, and they have the same exponential power to the second power. But Ms. Wilford, the number in the front is not the same. Remember in the rules here, it says the coefficients do not need to match. Oh, that's what that is? Yes, these are called coefficients. These are called coefficients. These numbers here that are in the front are called coefficients. These are considered coefficients and they do not need to match, but consider it like this. Now that you have the same variable and the same exponential power, you can add these together by adding the coefficients, saying 2 plus 3 would give you 5, and then this has to remain x squared. It's like saying apples and apples. 2 apples plus 3 apples gives you 5 apples. Whereas over here was x squared that says apples, whereas x is oranges. What's an apple plus an orange? You don't combine those because they don't have the same exponential power in this case. They're not the same. All right. Don't worry, there's going to be a lot of practice, and I'm going to explain this again for you. I know it's kind of quick the way I explain it. I just want you to know that in order for something to be a like term, it has to have the same variable and the same exponential power. I'm going to say that again. In order for something to be a like term, it has to have the same variable and same exponential power. Let me go down to the modeling to show you. Okay. Now, to start off with, before I dive into example 1 and example 2, just quickly look over here. This is considered a term. A term has 3 parts to it. It has a coefficient, which in this case is 8. It has a variable, which in this case is x. And it has an exponent, which in this case is 3. Okay, I'll say it again. It has a coefficient, which in this case is 8. Has a variable, which in this case is x. And has an exponent, which in this case is 3. Okay? And this is considered a term, one term. Every term is separated by a plus or a minus sign. Every term is separated by a plus or a minus sign. And in this case, there's only one term here. There's no other terms. If I looked at example 1, since a term is separated by a plus or a minus sign, a term is separated by a plus or a minus sign, how many terms do you think are in example 1? Okay, if you said 4, you are correct. Let me show you. 1, 2, 3, 4. They're separated by a plus sign, minus sign. There are 4 terms here. Okay, 4 terms in this first one. So I'm just going to put the number 4 over here, 4 terms. Okay, our goal today is to combine like terms. Now, what is a like term? It has to have the same variable. It has to have the same exponential power. So when I look at these, are there any like terms here? The answer is yes. What are they? And I'm just going to use different colors here to show you them, okay? 3x is a like term with negative x. Now, how do I know this? It has a variable. They both have the same variable, x. Cool. Do they have the same exponent? Yes, they do. What is that exponent? To the first power, to the first power. But Mr. Woodford, I don't see the exponent there. Remember, when you don't see a number, that means the number is a hidden number, which is 1. It means it's to the first power. Okay, so the first power here, first power there. I'm just going to rewrite these and say, okay, 3x minus x. Okay, those are like terms. What else is like terms here? Are there any other like terms? And the answer for that is also, yes, there are like terms. 6 and 3. Those are like terms. But they don't have the same variable or the same exponent. Yes, they do. Do they have a variable? No. Does the variable have an exponent? No, because there's no variable there. That means they're the same. And on top of that, you guys already know numbers are like terms. You've been adding numbers for forever. You know 2 plus 3 and 3 plus 4 and 6 plus 3. You've been adding numbers forever. So numbers are considered like terms. Numbers can be added to numbers. So I'm just going to put plus 6 plus 3. And all I did, ladies and gentlemen, was rearrange the order of my actual expression. Notice the only thing I did that made sure I changed it was kept the sign, which was in front of the x. That was a negative. Everything else was positive, but the x had a minus in front of it, so it had to stay minus in front of it, okay? Now, I'm going to combine these like terms. So what is 3x plus a minus x? What is 3x plus a minus x? Once again, this is one of those, you add now these coefficients. Remember the numbers, the coefficients are the numbers in front. You're going to add those. So what's 3x minus x? It's like saying 3x minus 1x. Because you don't see a number in front, that number in the front is 1. Just like these exponents here. These exponents here are 1, right? They have the same variable, same exponents. You can combine them. So what's 3 minus 1? 3 minus 1 is 2. Keep the variable, 2x. 6 plus 3, you can combine those to just simply get 9. So my added expression is 2x plus 9. That is my answer here. I can do nothing else. I cannot combine 2x and 9 because they don't have the same variable or the same exponent. Let me go on to example 2. Now, example 2, it walks you through, once again, I would ask yourself, how many terms are there? How many terms are here? Take a second. Remember, a term is separated by plus and minus signs. If you want to make a note here and say a term is separated by plus or minus signs. Okay, so how many terms are here? If you said 5 terms, you are correct. If you said 5 terms, you're correct. Let's count. 1, 2, 3, 4, 5. Okay, there are 5 terms here. The next question comes and say, okay, well, are there any like terms? Are there any like terms here? And I would say yes. X squared is like terms with negative x squared. Okay, is it like terms with x, 2x and 4x? No, but 2x and 4x are like terms because they both have the same exponent. I mean, the same variable and the same exponent. So, boom, 4x, 2x, and that means minus 4 is on the outs, right? It doesn't have a friend, but it's okay. Okay. Now I'm gonna rewrite them and I'm gonna combine them. Okay, I'm gonna rewrite them and I'm gonna combine them. Minus 4 stays over here all by itself, right? X squared minus x squared is over here. Plus 4x plus 2x. Okay, so these are my terms, right? All I did was rewrite them, keeping the signs that they're associated with in front of them. X squared minus x squared. It's like saying 1x squared minus 1x squared. Whenever you have something and you subtract that something, you should know that means that's 0. That cancels itself out. It's nothing. 4x plus 2x, right? Only add the coefficients here because we already identified that they're like terms. So 4 plus 2 gives you 6x. And we have to keep this actual constant as well, which in this case is minus 4. Notice I said it's a constant. It is a number, but we bring that number down because it's by itself. It's considered a constant because it doesn't have a variable next to it. All right, so our answer here will be 6x minus 4. All right, Before I end it for today, I'm going to mention one more thing on the notes section, and I also want you to fill in this table. Identify the coefficients, variables, and exponents of all four of these. I will do the first one for you, and I'll also do the last one here. The coefficient here is 8. The variable here is c, and the exponent is 2. Whereas this last one here, the coefficient is 12. Variables are a and b, and then the exponents are 2 and 3. Okay, fill in the rest of this chart. The last thing before we end it for today, I would like to make sure you know something. When you put your answers in, right, because sometimes I may give you something that looks like this: x to the third plus x to the second plus 2x to the third minus y, right? I may add different letters in there. It won't always just be x, right? It may be different letters. Notice here that there are different letters, right? You want to make sure your answers should be arranged so that the variables are in alphabetical order. Alphabetical order. Alphabetical order. Okay, so it should be in alphabetical order. Now, the exponent should be from the highest to lowest exponential power, right? So what do I mean by this? I mean, you would have it something like this: a to the fourth plus b to the third plus c to the second plus 3, okay, with the constant on its out, all right? You would do something like this, okay? Now, keep in mind, there are terms that I may give you that may be like xy plus 2xy, all right? They have to have both of the same variables. It can't just be, oh, wait, and maybe this one had 3x. Well, I can combine all three of them because they both have x. They have to have x and y. So the only ones that combine here is xy and 2xy. They cannot combine the 3x because it doesn't have both variables next to it. All right. Take your time. Go through the worksheet. Do your very best. You're going to combine like terms. And once you do that, you're going to also work on your homework, which will actual riddle question, which you can answer by combining like terms. All right. Thank you guys so much for joining me. Feel free to leave any questions or comments you have in the Google Classroom post area. That way I can be able to address them. You guys have a wonderful day. Looking forward to talking to you later. Bye-bye.